Unit 3. This is our meteorology unit. Within this unit, we're going to look at the atmosphere before we get to meteorology. Hopefully you remember this from Unit 1, so you don't need to write it down. But meteorology is the study of weather. But when we study weather, we first have to understand what's going on in the atmosphere, because all weather is a result of atmospheric processes. So that's what we're going to look at first, is the structure of the atmosphere. But before we get to that, let's look at the difference in weather and climate. So weather is whatever the current atmospheric conditions are, while climate is going to be an average of weather over a long period of time. So weather, the key word is current. That's why it's both bolded and all caps, and why I keep emphasizing it. But weather is whatever is currently going on in the atmosphere. So you could look out your window, and if you were going to describe whatever the weather is, you would just talk about what you see. For instance, while I record this, I look out the window, and the temperature is pretty warm, and it is sunny with clear skies. Those are my current atmospheric conditions. Weather constantly changes, though. Earlier this morning, it was really foggy and humid, and it was still pretty warm. But that just shows you how much it can change within a couple hours. Especially in North Carolina, weather's always changing. But your current atmospheric conditions could be that it's 30 degrees outside and snowing. It's just whatever is currently going on at that particular place at that particular time. When you look at climate, you're going to describe more of a general description. So for instance, for winter, you would say North Carolina has a mild winter. Yes, we do get snow. Yes, it does get cold, but our winter is nothing like Michigan winters. So it's just going to be the average of the whole region. So we're looking more at North Carolina than I am specifically what's going on exactly where I'm standing. So weather, current atmospheric conditions, climate, averages over a period of time, and it's going to describe a region. While you finish writing that down, I will show you these two graphs that are seen on the slide. This is what we call a climatogram. And if you notice, you can probably see it better on the top graph. These are made up of precipitation and temperature. So when we look at climate, we're looking at the precipitation and the temperature. And then we can make a fun little graph. And we actually will do this later on, so you can enjoy that then. But let's move right along. So let's look at how weather and climate compare. I'm actually going to do this for y'all to kind of save you some time. But whenever I ask, like, what's the weather outside? I want to know not just that it's raining, but I want to know, is it cold or is it warm? Because that's going to change drastically what I wear when I go outside. So when I ask about weather, I want to know both what is the temperature and what is the precipitation like. Climate, you're going to do the same thing. Whenever we describe climate, let's say it's of a tropical rainforest, we're going to say that it has a warm, wet climate. That means that the temperatures are on average warm pretty much year round, and wet as in it has a lot of precipitation going on. So whenever you describe weather, we look at both precipitation and temperature, and when we look at climate, we are also looking at precipitation and temperature. So those are the two things that it really has in common. So what's in our air? This is just a fun little activity. It's really just a way for me to give you some food to kind of bribe you into liking class a little bit more, but I never get complaints on that. So in just a second, you're going to be given a bag that has some Skittles in it. There's more than 10 Skittles in the bag, but what you're going to take out of the bag are 10 Skittles. And you're going to take out of those 10 Skittles, there's going to be 3 different colors. And those 3 different colors are each going to represent a different gas that's within our atmosphere. So one gas is going to be oxygen. Obviously, we breathe oxygen, so that's a really important one. We're going to look at carbon dioxide. That's the one that we breathe out. And we're also going to look at nitrogen. So you're going to get 10 total Skittles out of your bag, and you're going to break it up into 3 different gases. One color will represent oxygen. One color will represent CO2. One color will represent nitrogen. And so I want you to get those out just saying what proportion. So if you get out, say 2 Skittles for nitrogen, then that's you saying that you think about 20% of the atmosphere is nitrogen. So 10 Skittles total, break it down into 3 colors. Each color represents a different gas. which is going to show what you're guessing the composition of the atmosphere is. So I will go ahead and let y'all pause the video while you get your Skittles and you make your guesses. Okay, I hope you enjoyed your Skittles, but let's look at the air composition. So the main components of our air is nitrogen, oxygen, carbon dioxide, and then a gas, and I don't know why they always talk about this gas, but it's called argon. So nitrogen is the majority of what our air is made up of. 78, so almost 80% of all the air around you, the gas molecules are nitrogen. 21% of the gas molecules are oxygen. Less than 1% is going to be carbon dioxide, and less than 1% is going to be argon. Again, I don't know why the state wants you to know about argon as a gas, because it's what we call a trace gas. It's kind of random, but they do tend to ask you about that one, so make sure that you do remember it. A lot of students their typical guesses is that oxygen is the majority of the atmosphere. And that makes sense because that's what we breathe. So that's just what most people focus on. But it is not. Nitrogen is going to be about 80%, while oxygen is closer to 20%. Now, there is a good chance that your test questions will ask you about the percentages of these different gases. As long as you can remember about 80 and about 20 and then less than 1% for the carbon dioxide and argon, then you're okay. They're not going to give you answer choices that are like 78% nitrogen versus 75% nitrogen. They're not going to put numbers out that close. They just really want you to know that the majority or the most abundant gas is nitrogen. The second most abundant gas is oxygen. And then your trace gases would be under that. That's the main thing they are concerned that you know. So, and I always like to point this out. Look at how little carbon dioxide is. It's that little teeny tiny, like burgundy-ish looking line. Very, very small. And yet, there's so many people talking about how there's too much carbon dioxide in the atmosphere, creating global warming. Well, sometimes people will look at this pie chart and they think, well, there's barely any carbon dioxide in the atmosphere. How's there's too much? Well, let me ask you a question. If I gave you a glass of water and I said, well, I only put 1 drop of poison in the water, you're still not going to want to drink that glass of water because a little bit of a bad thing can be too much. When we're looking at the earth likes to be balanced, which we have talked about. And it's a system. So if you affect one part of the system, it's going to affect another part of the system. So even though carbon dioxide might be such a small proportion of our atmosphere, if you just get that a little bit out of whack and a little bit too much, it can actually cause some very big, significant changes because, again, affect one part of the system, you're going to affect the rest of it. And that's what we're seeing with global warming, which we'll talk about more later. So hopefully you have our different gas components written down so we can move on. So this is just looking at 3 particular gases in the atmosphere. We have water vapor, and notice water vapor was not in that pie chart, and that's because water vapor, due to the water cycle, is constantly changing. If it's a really foggy morning, then you're going to have a lot of water vapor in the atmosphere, so the percentage may look higher. But if it rains and all that water vapor, the gas, is now liquid and on the ground, well, now that number is going to go down. So they don't include water vapor in the pie chart because the water cycle is constantly changing the numbers. Carbon dioxide, but water vapor is the source of all of our clouds and all of our precipitation. So as we look at weather, that's obviously going to be a very important gas for us to look at. Carbon dioxide, one of the main things that it does, one of its main jobs in our atmosphere, is absorbing energy. And as you probably have figured out, I don't wait a long time for you to write things down because I'm a big believer in you learning to take notes faster because you're going to have teachers in the future, especially professors, who aren't going to wait around for you. So one of the best things to do is to start making abbreviations for words so that you can go faster. So Whenever I first write an abbreviation, the first time ever, if it's a word I know I'm going to use a lot, then I always write I'll make the abbreviation. So here you see I have a capital E, and then right next to it in parentheses, I put energy. That way I have this abbreviation in my notes, but if I'm ever flipping back through my notes and I'm thinking, well, what on earth does a capital E stand for? I have a code, right? The first time I ever use it, I have a code, so that way I can know it. I came up with this capital E for energy thing when I was in high school because my biology teacher went so fast, and it stuck with me even till today. So that is something that you will see quite often. And then you'll notice instead of writing out the entire word precipitation, precip is really all you need to write. So anyway, carbon dioxide, it absorbs energy. It's what we call one of the greenhouse gases, which we will talk about more later. But it traps heat within the earth. So that's one of its main jobs. And then you have a gas called ozone. Ozone is also in our atmosphere, and it absorbs our harmful UV radiation from the sun. Now, this is a very big thing, something that we are all very, very thankful for. Because UV radiation, well, think of what's a disease that it's known to cause. Cancer, particularly skin cancer. So if we did not have ozone in the atmosphere to absorb these rays, a lot more people would get sick. I do want to point out, this is just a chemistry thing, oxygen is O2. It's 2 oxygen molecules put together, and ozone is just O3. So I think it's interesting to see how just one more oxygen molecule combined can create such a different gas that plays such an important role in the atmosphere. I just think that's kind of neat. But anyway, let's just keep on going. So we are going to make a foldable. So right now I want everybody to put their pencils down. You are not going to write for the next bit of our notes. I'm going to quickly go through them. And then when I'm done, we're going to pause the video so that you can make a foldable and write the notes down that way. It's pointless for you to write everything as I talk and then to rewrite again in a foldable. So the foldable will count as your notes for this section. And these are the instructions which I will come back to. So the first layer of the atmosphere, and again, no one should be writing, is the troposphere. This is the layer of the atmosphere that we live in, that you're standing in right now. There is a main event that occurs within the troposphere, and that is weather. So I am going to talk about events of each layer, and so the main one here is weather. All weather occurs in the troposphere. As you go up, your temperature goes down. So as you increase in altitude, meaning going higher in the atmosphere, it's going to get colder. And that should make sense because if you ever look at mountains, you're driving past them, then typically the very tips of the mountains, the really high ones, are going to have snow. That's because they have a higher altitude, so they're going to be colder. Then your air density lowers. So if you also go on top of a really tall mountain, especially somewhere like Mount Everest, you have to pack oxygen with you. Because as you go that high up, there's less and less gas, there's less and less oxygen, and so you can't breathe. So temperatures go down, density goes down, and then when you get to the next layer, right beforehand, we have the boundary, and the boundary is what we call the tropopause. So if I tell you to pause, I'm telling you to stop. So the tropopause is saying the troposphere has stopped, and it's going to move into our next layer of the atmosphere, which is the stratosphere. Well, before we do that, here's some fun facts. The troposphere is the shortest layer of the atmosphere. It's only about 7 miles high, but it has 75% of all the gases. Now, that's not stuff you need to memorize, but just some interesting information. The reason the troposphere is warmer and then gets colder as you go up is because the troposphere is heated by the surface of the Earth. Because the surface of the Earth is what's absorbing the sun's radiation. And so as you get further from the surface of the Earth, it's simply going to get colder and colder. So now our next layer of the atmosphere is the stratosphere. The stratosphere is on top of the troposphere, and it contains the ozone layer, and this is also where planes fly. So in this particular layer of the atmosphere, we have 2 main events. You have the ozone and planes. As you go up in the stratosphere, the temperatures actually get warmer. So it's the opposite. Go up in the troposphere, it gets colder. Enter the stratosphere, and it now gets warmer. The boundary here is called the stratopause. So a couple more fun facts about the stratosphere will be on our next slide. And the reason planes fly here, one is because there is less gas, because as you go up in every layer, air gets thinner, 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 and thinner. Our temperature will vary, but one consistent thing for every single layer of the atmosphere is the air always gets thinner. The density goes down, okay? The air pressure goes down. Because there's less air, less gas molecules, there's less friction. So if planes are flying in the stratosphere, they can actually have less gas because there's less resistance as they move through the air. But another big reason is if you're flying in a plane, the last thing you want to do is fly through a thunderstorm or a tornado. So if you can fly above where weather is happening, then you're typically going to have a safer, more enjoyable plane ride. So why is it that the temperatures in the stratosphere get warmer as you go up? That's because the ozone layer is there. And the ozone is absorbing all of the sun's energy. And so the closer towards the sun you're getting, the warmer that layer gets. So our next layer is called the mesosphere. This is above the stratosphere, and this is where meteors occur. I always remember that meteors occur in the mesosphere because they both start with an M. So if that helps you remember it, meteors in the mesosphere because they both start with an M. The boundary for this one is the mesopause, not menopause, mesopause. So the mesopause is where this stops. And as you're going up in the mesosphere, again, your air pressure is going down, your density is going down, but your temperature is also going down. So as you increase in the troposphere, it gets colder. The stratosphere gets warmer. Mesosphere, again, is going to get colder. And here's some more fun facts. So the mesosphere is actually one of the layers of the atmosphere we know the least about because it's too high for planes to fly in, but it's also too low for a spacecraft. So it's really hard to study it. If you were to go in the mesosphere without a spacesuit, though, your blood would boil. And that all has to do with the pressure. Let's see. Most of the heat, the reason why it gets colder is because most of the heat in the mesosphere is just residual heat from the stratosphere with the ozone layer. And so then as it gets further from that stratosphere, it just gets colder. But meteors burn as they fall through the mesosphere, and that has to do with friction. The friction heats those meteors up so hot that they will burn up pretty much completely without ever entering the lower layers of the atmosphere. So our last layer of the atmosphere is the thermosphere. And so whenever you think therm, you probably think heat or temperature. Like you put your coffee in a thermos, that's to keep it warm. So your thermosphere is the last layer, and it gets warmer as you go up. The event that occurs here is the northern lights. They're also called the auroras. I always call them the northern lights. Very, very beautiful, but they are in the thermosphere. The thermosphere fades into space, also known as like the exosphere. Now in middle school, y'all probably talked about the exosphere when you talked about the different layers. We're not going to talk about that because as far as we're concerned, the thermosphere is so thin, the gas layers in it, that we consider it pretty much outer space. So we don't talk about the exosphere. However, you know it exists. There it is. The temperatures in the thermosphere can get so warm, they'll be about 4,500 degrees, which is absolutely ridiculous. Even though it's 4,500 degrees, it would still feel cold to you if you were up there. And that's because you have to have gas molecules to transfer heat. And so because the air is so thin in the thermosphere, it is very warm, but it would have trouble transferring that heat there for your body to feel it. However, if one of those gas molecules hit your body, it would burn straight through you. The International Space System is also in the thermosphere, which I just think is kind of interesting. And let's see, I think that's pretty much about it. Although the International Space System is in the thermosphere, the main thing we're concerned about is the fact that the northern lights occur there. That's the main event that we're looking at, not the space system. That's just a fun fact for you. Okay, so what I want you to do now, before we get to the foldable, because I have a couple more things to tell you before we get to that, is to create an acronym. Because this is a study method, you will need to know the order of the different layers of the atmosphere. So a couple acronyms, like one would be KEY, keep educating yourself. So each letter in an acronym stands for a particular word. Or you have SMARTER, so you probably learned about a SMART goal from your PE or health class. Specific, measurable, agreed, realistic, time-bound, ethical, recorded, all that stuff. So I've written down for you the different letters that you're going to talk about. T starting for troposphere, the first layer. So this is where the ground is. So here's a little tree. Stratosphere, mesosphere, and then thermosphere. So I have TH for thermosphere to help you remember which one is troposphere, thermosphere. Use these letters and you're going to come up with some sort of phrase. I don't care if you're going to have a phrase that goes from TH down or from T to TH. It doesn't matter to me. But it needs to go in order and it needs to start with those letters. Okay, hopefully you came up with some interesting acronyms, some good ones to help you remember this. One student last semester came up with one that said, "This school makes thinking hard." That was a fun one that they used. The acronym that I have always used, a student actually came up with it, was Toy Soldiers March on Thursday. And so it goes from the bottom up because I'm talking about the bottom layer of the atmosphere up. And I like this one because, well, it's just easy to remember, but Toy Soldiers March on Thursday, and the TH to help you remember the thermosphere. So acronyms are always a good thing to help you remember stuff, especially if it has to be in order. So that is just a good study tool. So hopefully you will now remember all the layers of the atmosphere in order and never ever miss those. So a couple of last things, pressure and temperature changes. So the atmosphere rapidly thins the further away from Earth you get. Now this is something that I already mentioned, but you can see this in this picture of Mount Everest. How much air, how many gas molecules, it's less and less and less as you get up closer to space. So we already know that temperature decreases in the troposphere, increases stratosphere, decreases mesosphere, increases thermosphere. So temperature goes either way, but your pressure and density always lowers. Every single atmospheric layer, the pressure and the density is always getting lower, so that should make things easier for you to remember. So this is just a picture of the density, and remember, density is how much stuff is in the area of space, and the stuff that we're looking at here are your gas molecules. Now, on your foldable, you are going to have to draw density bubbles, and I'm going to have example foldables for you to look at, but this slide is showing you another example of those density bubbles. Down here at the thermosphere, you have the most gas bubbles, so it goes from the most to the least, and then it continues to get lower as you go up. And that's just showing you that your density is decreasing the entire time you move away from the Earth. So temperatures, again, as you go up in the troposphere, it gets colder, and we know that because of mountains. They alternate. As you go up in the stratosphere, it gets warmer. The mesosphere, colder. The thermosphere, warmer. And this is just showing you one of those atmospheric graphs. So over here in the corner, you can see the graph and notice it gets colder, warmer, colder, and then it will start to get warmer again. And so you know this is my troposphere, stratosphere, mesosphere, thermosphere. And then you've got the layers. So you've got Mount Everest and some weather going on in your troposphere. Here's your plane and your ozone layer for your stratosphere. You've got a meteor in your mesosphere. And the thermosphere, they didn't draw it, but you would have your northern lights. So we'll pretend that's northern lights. So that is just a big summary of all of your atmospheric layers. Again, this is another graph just showing you those temperature changes and how they alternate. So if you can really just remember the troposphere temperature changes and you know they alternate, then you can just figure out the rest of them. So now we are going to make your foldable. Yay, how exciting. So each person is going to need 3 pieces of paper to make this foldable. Here are the instructions for the foldable. We will end up pausing the video on this so you can see it. You're going to staple the foldable. So the way that you make this is you line your 3 sheets up, and they're a little bit off, and then you fold it over and you're going to staple it. So when you staple it, you're stapling it up by the thermosphere. Now, this picture has exosphere in it. Again, we didn't talk about the exosphere, so you don't have to include that. As you'll see in my foldable layers, I just called that space, and I didn't write anything under the flap. I just drew like a little alien or something for fun. But for each flap, there are very specific things I'm looking for. And I am going to grade these specifically based on the instructions. Some students will put all this information in their foldable, but none of it is the information I asked them to put. So I do give them a 0. So make sure you are following instructions. So under each flap, there are 4 things that you need to have included. How does the temperature change as you increase in altitude? What event occurs there? Weather, planes, whatever. What's the density like? And then the name of the boundary or the pause. Okay, so tropopause, stratopause, that thing. So 4 things should fit under every single flap. The only flap that will not have 4 things is the thermosphere, because the thermosphere does not have a thermopause. It just fades into space. So that's the only one that will have 3 things. The rest will have 4. Now, if you put 4 things, but it's not these 4 particular things, then I'm not interested in that, okay? These are the 4 things that your grade is based on, so make sure you follow instructions.